Okay, let's unpack this. Every single day, you're interacting with technology, tapping on your phone, streaming a show, connecting with colleagues online. But have you ever paused to think about the incredible, invisible infrastructure that makes all of that possible? Today, we're taking a deep dive into that very backbone, IT infrastructure, the soaring world of cloud computing, and perhaps most crucially, how organizations strategically manage the vital risks that come with it all. Our mission is to take a stack of fascinating sources on these topics and distill them into clear, easy to understand insights, giving you a real shortcut to being well informed, whether you're prepping for a big meeting, you're just curious about tech, or you simply want to feel more in control of the digital world around you. We're aiming for those aha moments.
Yeah, and what's truly fascinating here is how these seemingly separate areas are so deeply intertwined. They don't just shape your phone's apps, they influence global businesses, whole economies even.
Yeah.
Understanding their connection isn't just for IT professionals, it's vital for anyone navigating today's information-rich landscape. From the fundamental building blocks of a computer right up to the cutting edge of cloud strategy.
So let's start at the very foundation then. What exactly is IT infrastructure? Think of it as the entire technological ecosystem that supports a modern company.
Hmm.
It's a blend of what a company owns and manages directly on its premises, alongside, well, an increasing reliance on outsourced hardware, software, and specialized personnel. It's the whole complex setup.
And because so many organizations now rely on external providers for parts of their IT operations, we're seeing an aggressive growth in something called SOC2 engagements. Right. These are essentially third-party audits. An independent firm evaluates a service organization's system controls against 5 key criteria: security, availability, processing integrity, confidentiality, and privacy. They're critical because they give users, like you or the company, using the service, reasonable assurance that the controls are effective and reliable.
Okay, so like a stamp of approval for their systems.
In a way, yes.
Mm.
And for the auditors doing this work, it requires more than just basic IT knowledge. It demands real technical expertise across modern operating systems, network setups, devices, hardware, the works.
Speaking of hardware, let's zoom in on computer hardware itself. Broadly, these are the physical components, right? The stuff you can touch.
Exactly.
Now, here's an interesting distinction I found. We have end-user devices, or EUDs, and non-EUDs. EUDs are what you probably think of first: your laptop, tablet, maybe your smartwatch. They're the machines that directly interact with people, often at the edge of a network.
That's right. The things you use day to day.
Non-EUDs, on the other hand, are more like the workhorses behind the scenes.
Mm.
Think of the big servers crunching data, the network switches routing information, or the powerful routers connecting everything. These are typically used by programmers, administrators, or developers to build and maintain the actual infrastructure.
Yeah, it's like the difference between the car you drive and the robots on the assembly line that built it. Both hardware, but very different roles. And inside those machines, you've got those core components, the microprocessor, that's the brain, doing the calculations.
Right.
Then there's RAM, random access memory, which is its short-term memory, holding data it's actively using.
Okay, temporary storage.
Exactly. The hard drive is the long-term vault for permanent storage. Plus, you've got the motherboard, which is like the central nervous system connecting all these pieces. Power supply, too, obviously.
And outside the main computer box, you have all the external computer hardware, your mouse, keyboard, speakers, monitor.
Peripherals, yeah.
These help you interact with the machine. They can be wired or wireless. Even printers and scanners fall into this category.
And while not hardware themselves, the facilities that house all this hardware are absolutely crucial. We're talking about data centers or dedicated office spaces.
Right, the physical building.
Packed with advanced security, high-tech locks, surveillance,
Yep.
and vitally sophisticated ventilation and climate control. Keeping things cool is a huge deal to prevent expensive equipment from overheating.
Makes sense. That's all part of the broader infrastructure picture.
Absolutely. It keeps our digital world running.
So we've covered the individual puzzle pieces of hardware, but imagine a pile of high-tech bricks. They're pretty useless without the mortar and the blueprint to connect them.
Good analogy.
That's where the nervous system of the digital world comes in. Network infrastructure. How does all this talk to each other?
Exactly. Network infrastructure is all about the hardware, software, and the underlying design, the layout that enables communication between all those devices. When we talk about the core network hardware, maybe think of 3 primary roles that really enable your internet experience and keep data flowing. First, your modem. This is like your internet's front door. It connects your internal network to your internet service provider, your ISP, It translates the signals so your devices can understand them. Every modem has a unique public IP address, like a specific street address on the internet.
Got it. The gateway to the outside world.
Precisely. Second, the router. If the modem is the front door, the router is the traffic cop inside your network. It manages all the data traffic, connects your devices, and figures out the most efficient paths for data packets to travel to their destination. It usually sits between your modem and all your other devices.
Directing the traffic internally.
Right. And third, the firewall. This is your network security guard. It can be software or a dedicated hardware device. A firewall filters network traffic based on strict security rules. Its job is to prevent unauthorized access and stop malicious downloads. Basically, protect your network from threats.
Super important. So modem, router, firewall, key hardware pieces. But how are they physically laid out? You mentioned layout.
Ah, yes. That's network infrastructure, physical layout, or topology. It's the physical arrangement of all these nodes, the devices in a network. And how you arrange them directly impacts how efficient and resilient your network is. There are trade-offs.
Like what?
Well, consider two common types. You have star topology. Imagine all devices connected to a central hub, like spokes on a wheel.
Okay.
If a cable to one device breaks, only that device is affected. Makes troubleshooting easier.
Oh.
But that central hub is a single point of failure. If it goes down, the whole network section goes down.
Ah, okay. Vulnerable center.
Then there's mesh topology. Here, there are multiple, often redundant connections between devices. In a full mesh, every device connects to every other device.
Wow, that sounds complicated.
It is, but it offers incredible reliability. If one connection breaks, data simply reroutes through another path. The downside, it's incredibly complex and costly to set up and maintain, especially in large networks.
So a trade-off between simplicity and cost versus redundancy and resilience.
Exactly. It shows how you balance reliability against cost and complexity. There are others too, like bus and ring, each with their own pros and cons.
Okay, so once you have your hardware arranged, the next layer is making them speak the same language, right? Like rules for sending data.
Precisely. It's like having a postal service for your data, but needing clear rules for addressing envelopes, packaging items, and deciding the route. That's where network infrastructure protocols come in. And they're often visualized through something called the Open Systems Interconnection Model, or OSI model.
The OSI model, I've heard of that. 7 layers.
That's the one, 7 layers. And its real genius isn't just listing 7 steps. It's how it acts like a universal translator and a really precise diagnostic tool for the entire internet. Think of building a house. Plumbers, electricians, carpenters, they each have their own standardized tasks. The OSI model lets different companies build network gear that always works together. And when something goes wrong...
You know which layer to check.
Exactly. Instead of guessing, you know which floor of the network stack to investigate. Think of it like a journey for your data. When you send an email, it starts at the top, at layer 7, the application layer. That's where your email app talks to the network using protocols like HTTP or SMTP.
Okay, the user-facing part.
Right. As your email travels down through the layers, each one adds more information, like adding an address label, postage, handling instructions to a package. This process is called encapsulation.
Adding layers of info.
Yep. Layer 6, presentation, handles formatting, encryption. Layer 5, session, manages the dialogue. Layer 4, transport, ensures data integrity using protocols like TCP. Then Layer 3, the network layer, is crucial for routing. It adds IP addresses, like the Postal Service figuring out the best path across different networks.
Using it to the right neighborhood.
Exactly. Layer 2, data link, adds MEC addresses like the specific house number. And finally, at the bottom, Layer 1, the physical layer, your email becomes raw electrical bits or light pulses, ready for transmission over cables or Wi-Fi.
And at the receiving end.
The process reverses. Each layer strips off its corresponding information, that's decapsulation, until the email reappears at layer 7, ready for the recipient's app.
Wow. Okay, so each layer builds on the previous one for seamless communication.
Precisely.
And speaking of the overall picture, we also need to consider network infrastructure architecture. This sounds broader.
It is. It refers to the holistic design of an organization's network, considering its geography, physical setup, and logical layouts altogether.
Like different types of networks.
Exactly. You're probably familiar with some common examples. LANs, local area networks, cover a small area, like your home or a single office.
Right.
Then you have WANs, wide area networks. These span much larger geographic areas, connecting multiple LANs across cities, countries.
Yeah.
The internet itself is the biggest WAN. We also see SD-WANs, software-defined wide area networks, which use software to optimize WAN connectivity, making it more flexible. And VPNs, virtual private networks. These create secure, encrypted tunnels over a public network, like the internet, allowing you to safely access, say, your company's network from home.
Got it. So LANs, WANs, VPNs, different scales and ways of connecting securely. Moving on from the physical and connective element, let's talk software. This is the non-physical brain, right? The instructions.
Exactly. Applications, procedures, programs.code that tells the hardware what to do.
And central to that is the operating system, the OS.
Absolutely. Think of the OS like Windows, Mac OS, Linux, Android, iOS as the conductor of an orchestra. It manages everything. It orchestrates the global functioning of all your apps and hardware, acting as the intermediary so you can actually get tasks done. It handles memory, processes, devices, the user interface, making sure everything runs smoothly, even when you're multitasking.
Okay, the master controller software. What about firmware?
Firmware is a bit different. It's software that's embedded directly into hardware components,
Yeah.
like a set of hardwired instructions on a motherboard or a microprocessor chip. It tells that specific piece of hardware how to operate at a very basic level. Unlike your OS or apps, firmware is rarely, if ever, updated by the end user.
Gotcha. Lower level baked into the hardware.
Right. And an exciting extension of this software world, blending hardware and software, is mobile technology.
Phones, tablets.
Yep. Any wireless-enabled device connecting to private networks or the internet. It enables real-time communication and business operations from almost anywhere. It combines the hardware, laptops, tablets, phones, even mobile hotspots with mobile apps and mobile operating systems. Connectivity happens via Wi-Fi, Bluetooth, or cellular like 4G, 5G.
And these can be EUDs or non-EUDs too?
They can. A smartphone is clearly an EUD. But things like wireless routers, switches, firewalls, or access points that use mobile tech are non-EUDs.
Okay. And this leads into the Internet of Things, IoT.
It does. IoT devices are really an extension of mobile tech.
Yeah.
They usually need Bluetooth or an internet connection to function and connect to the wider network. They often have a more limited range or function compared to a smartphone, but they're everywhere now. AI assistants, smartwatches, smart thermostats, smart fridges.
More and more everyday objects joining the network.
That's the idea. Everything talking to everything.
All right, now let's reach for the sky, literally and figuratively, because we're heading into the world of cloud computing.
The cloud, yes.
This is a computing model using shared resources over the internet. So instead of buying and maintaining all their own hardware, customers essentially rent storage space, processing power, or software from remote servers owned by another company.
Exactly. And the core benefit here is something we call infrastructure elasticity.
Elasticity, like a rubber band.
Sort of. Imagine a retailer.
Yeah.
They need massive server power for Black Friday, their absolute busiest day. If they use traditional on-premises hardware, they have to buy enough servers for that peak day. But for the other 364 days, all that expensive infrastructure just sits there, underutilized, costing money.
Right, very inefficient.
With cloud computing, they rent only what's needed. They pay for usage, sometimes even by the minute or second. They scale up capacity for Black Friday, then scale right back down afterwards. Immense cost savings.
That makes a lot of sense.
Plus, you get other efficiencies. Data often resides in one virtual location, easier access, reduced need for internal IT hardware support, and distributed redundancy across multiple data centers reduces the risk of data loss from a disaster or attack.
Okay, powerful benefits. Now, when we talk cloud, it's crucial to understand the three primary cloud computing models, right? And how they compare to the old way, on premises. The key seems to be the level of control the organization keeps.
That's the core distinction, yeah. Control shifts.
So first, on premises, traditional approach. The organization manages absolutely everything. The physical data center, networking, storage, servers, operating systems, applications, the whole shebang.
Most control, but also most responsibility, most cost.
Right. Then we move to the cloud with IaaS, infrastructure as a service.
IaaS. Here, the cloud service provider, the CSP, provides the basic building blocks, virtual servers, storage, hardware, networking, like renting the raw computing power.
So the organization manages its own virtual environment, the OS, the apps, but the CSP handles the underlying physical stuff.
Exactly. You still have significant control over your virtual setup, but less than on-prem.
Okay. Next level up is PaaS, Platform as a Service.
PaaS. Here, the CSP provides not just infrastructure, but also platform often proprietary tools or solutions for specific tasks, like building web apps or managing databases. The CSP maintains all the back-end infrastructure and the platform tools. Your organization just focuses on developing and running its applications on that platform. Less control again.
So you're renting the workshop and the tools, not just the building.
Good way to put it. And finally, SaaS, software as a service.
This is probably what most people interact with daily, right? Like webmail or online office suites.
Absolutely. With SaaS, the CSP provides a complete business application or software, typically via subscription. Think Salesforce, Microsoft 365, Google Workspace. The CSP is responsible for everything. Upgrade, security, support, infrastructure, platform. You just use the software.
Yeah.
Least control, but maximum convenience for that specific application.
And you mentioned BPay, business processes as a service.
Yeah, that's kind of an extension of SaaS. It's where a third party uses SaaS software to deliver a specific business function for you. Outsource payroll, using ADP, for example, or outsource billing services. They use SaaS tools to run your process.
Got it. So on-prem, IaaS, SaaS, a spectrum of decreasing control and increasing reliance on the provider.
Precisely. And beyond these service models, there are also different cloud computing deployment models. This is about how the cloud environment is shared or not shared.
Okay, different ways to deploy.
Right. First, public cloud. This is owned and managed by a CSP, like Amazon Web Services, AWS, Microsoft Azure, Google Cloud Platform, GCP. It's available to the general public or many organizations sharing the same underlying infrastructure. Multi-tenant.
Shared resources.
Then, private cloud. This is created for a single organization. It can be managed by the organization itself or by a CSP, and it can live on their premises or off-site. But it's dedicated infrastructure.
More control, more security, perhaps.
Often, yes, but usually more expensive. Then you have hybrid cloud. This mixes two or more clouds, typically at least one private and one public. They remain unique entities, but technology allows data and applications to move between them. Gives you flexibility, keeps sensitive data private, use public cloud for less critical tasks or bursting capacity.
Best of both worlds, potentially.
Potentially. And lastly, community cloud. This is shared by multiple organizations that have a common interest. Maybe they're all subject to the same strict regulations, like high pay for healthcare, or they share a specific mission. They pool resources for a shared, compliant environment.
Interesting. So public, private, hybrid, community, different sharing models. And the companies providing these are the cloud service providers, CSPs.
That's right. The third parties offering these services, hosting, delivery, monitoring. They handle the maintenance, the tech support for the hardware and core platform. CSPs usually have deep expertise in managing these massive, complex environments. And a key point, especially for public clouds, is that multi-tenant approach. They serve many customers using common resources. It's how they achieve economies of scale.
And details about how these CSPs operate, their security, their compliance, that often shows up in those SOC2 reports you mentioned earlier.
Exactly. SOC2 reports often detail how a CSP meets compliance requirements, maybe for EPA security rules or standards like the Cloud Security Alliance's Cloud Controls Matrix. They're vital for due diligence.
Which brings us neatly to a crucial topic, navigating the risks. How do organizations manage all this?
This is where frameworks like the COSO Enterprise Risk Management Framework come in. COSO provides comprehensive guidance for internal control, governance, fraud deterrence. It's widely respected. It categorizes methods for addressing organizational risk into 5 components, backed by 20 underlying principles. Think of it as a structured roadmap for identifying, assessing, and responding to risk.
Okay, a framework for managing risk. And when we apply COSO to cloud computing, what's the big takeaway?
The absolute critical takeaway, and one that sometimes trips people up, is that ownership of risk remains with your organization, even when you outsource functions or data to a CSP.
Really, you can't just hand off the risk?
Nope. You can outsource the activity, but not the ultimate responsibility for the risk associated with it. Proper governance is vital. Maybe you set up a cloud computing steering committee to oversee decisions and risks.
So you need to understand how your CSP affects your risk profile, how their performance impacts your operations.
Precisely. What are their responsibilities versus yours? Take firewalls. A CSP might provide the firewall capability, but you might be responsible for configuring the rules correctly. If you mess up the configuration, that's your risk.
Right. Or if the CSP has a major outage.
Your systems go down.
Yeah.
That impacts your business, your reputation, your bottom line. And crucially, isn't a one-time thing. Organizations must continuously update and reassess their risk management as their cloud needs evolve or they switch CSPs.
So the COSO framework helps structure that thinking.
It does. Its components guide you through the process. Assessing your internal environment, what's your risk appetite for outsourcing? Objective setting, how does cloud help or hinder your goals? Event identification, how does cloud change what could go wrong? Then risk assessment, what's the likelihood and impact? Risk response, avoid, reduce, share, or accept the risk. Control activities, how do controls change in the cloud? Information and communication, how does data flow? And monitoring, how do we keep tabs on everything? It provides a thorough checklist.
Okay. So what are some of those common cloud risks companies actually face when they're looking at CSPs or specific services?
Well, the sources highlight quite a few common ones. There's the risk related to the rate of competitor adoption. Are you falling behind? There's the risk of being in the same ecosystem as your CSP and potentially hundreds of other tenants.
Shared fate, almost.
In some ways, yes. Transparency can be an issue. How much visibility do you really have into the CSP's operations? Reliability and performance are always concerns. And a big one, vendor lock-in. Lack of application portability. It can be really hard and expensive to switch CSPs if you build everything on their proprietary tools.
Ouch. Trapped.
Can feel like it. Then there are the obvious ones. Security and compliance risks, cyber attacks, data leakage. Also, the impact on your internal IT organization skills might need to change. And even the long-term viability of the CSP itself. What if they go out of business?
That's a sobering list.
It is. And it's crucial to grasp the relationship between control and risk here. Generally speaking, risk increases when you move from a private deployment to a public deployment model.
More sharing equals more potential exposure.
Right. And similarly, risk generally increases with less control when you move along the service models, from IaaS to PaaS to SaaS. The more you hand over management, the more you rely on the CSP's controls and processes, and the more inherent or shared risk you take on. It needs very careful management.
This makes cloud evaluation and adoption really critical. You mentioned understanding other tenants in a shared cloud.
Yes, especially in public clouds. Their behavior, their risk profile can potentially impact you because you're sharing resources. It means your own ERM needs to consider that wider environment.
And companies obviously need to weigh implementation time, cost, and those compliance risks we talked about.
Absolutely. Which brings us to a really interesting case study that makes these trade-offs concrete. Fingard Financial.
Okay, let's hear it.
Fingard, a global market infrastructure operator, needed to outsource its clearing and settlement for real-time stock trades. High stakes, high volume. Their CFO looked at 3 cloud partner options.
Option 1.
Option 1 was Misroke. They housed up to 50 other companies per computing machine. Pricing was based on relative usage. The huge risk. A sudden stock trading frenzy, maybe driven by one of the other tenants, could overload and crash the entire shared platform. Catastrophic for Fingard.
Yeah, that sounds terrifying for a financial operator. Option 2.
Option 2 was Cliff Clearinghouse Partners. They offered a completely custom-built, dedicated platform. No sharing of physical space or computing power. It was most expensive, costing 5% of trading fees, but also the most secure, with advanced computing and backup platforms for redundancy.
Dedicated, secure, but pricey. And option 3.
Option 3 was R&M Group. They offered shared cloud hosting, but with a maximum of only 2 other companies on the same machine and location. Pricing was on demand, a fixed rate per hour. This significantly reduced the risk compared to Misroke because of the limited sharing.
Okay, a middle ground in terms of sharing and risk. So what did Fingard choose?
They chose option 2, Cliff, the dedicated platform.
Even though it was the most expensive.
Yes. Even though option 3 offered competitive pricing and much lower risk than option I, Fingard, being a major global market infrastructure operator, decided the premium for a completely dedicated non-shared platform was worth it. The risk of option I, a platform crash during a trading frenzy, was simply unacceptable given their business.
Wow, that really highlights how risk appetite and the specific nature of the business drive these cloud decisions. It's not just about cost.
Not at all. It's a complex calculation of risk, cost, performance, security, and business needs.
So, given these complexities, what are some recommended risk responses for organizations using the cloud?
Well, strong policies are key. Implement clear rules for data classification. What data can never go to a certain type of cloud, for example. This helps reduce unauthorized or risky cloud activity by employees. Conduct periodic, thorough assessments of your CSP's control environment and their management oversight. Don't just rely on their marketing materials. Dig into those SOC reports and ask questions.
Due diligence.
Absolutely. Have a robust incident management plan specifically for cloud-related cyber attacks. Know who does what when things go wrong. Develop clear CSP exit strategies before you need them. How would you get your data out? How would you transition to another provider or back in-house? This combats that vendor lock-in risk.
Plan your escape route.
Essentially, yes, and continuously monitor the regulatory environment. Rules change, especially around cross-border data flows. Non-compliance can lead to big fines and reputational damage, potentially requiring disclosures for public companies.
Stay vigilant. Wow. Okay. We've unpacked a lot there. The layers of IT infrastructure, the different models and deployments of cloud computing, and critically, how companies navigate the vital risks involved. It's a huge landscape.
It really is. But hopefully breaking it down helps.
Definitely. Hopefully you, our listeners, have gotten some clear, actionable insights and maybe a few of those aha moments.
Yeah, and if we connect this back to the bigger picture, it means recognizing that the technology powering our lives,
Yeah.
from that quick instant message to a massive global financial transaction, is all part of a carefully constructed and managed ecosystem. Security, reliability, careful risk assessment,
Yeah.
they're absolutely at the core. Understanding these concepts, even at a high level, empowers you to be so much more informed, whether you're a professional in the field or just, intensely curious about the digital world we all inhabit.
So, what does this all mean for you? Here's a final thought to chew on. As technology keeps evolving at this breakneck speed, we're talking AI, quantum computing, things we can barely imagine yet. How might these fundamental IT infrastructure and cloud principles we've discussed today need to adapt? And maybe more importantly, what entirely new risks, new challenges might emerge in this ever changing, increasingly interconnected landscape? Something to think about. Keep exploring.